Hey everyone, good morning. I am Jaskaranjit and I have been working with CRED for 2 years now, and I specifically work for the CRED Mint team. So today we are going to be discussing briefly about what step functions are and the kind of challenges that we have faced using step functions and how we kind of leveraged Kong to fix for that. Right? So we'll quickly start with what step functions are. Right? As per the definition of AWS, step function is a low-code visual workflow service that developers use to build distributed applications, automate IT use cases, business use cases, right? And kind of quickly build pipelines to kind of adhere to the product needs, right? And the I would say the advantages of, we'll probably discuss advantages in detail, but quickly discussing about advantages that workflows kind of manage retries, exception handling, all of that implicitly, right? So we don't have to write a lot of extra code. This is like a very technical definition, and if we just kind of simplify this, yeah. So in simple words, right, it is a serverless orchestration, right, where you can orchestrate multiple steps into a simple workflow, which will kind of adhere to your business needs. And the step function, the AWS provides a very simple workflow studio where you can kind of drag and drop the components and create a workflow out of that. And at any point in time, step functions maintain the inflow of the data. It kinds of maintains track of the input data, output data, exceptions, right? Which allows the users or the business use cases to resume from where the user might have dropped off due to network latencies or in general the drop-offs in the funnel. So this is mainly what step functions are, right? Coming to quickly discussing the advantages of step functions. They are very easy to build and deploy. AWS has given a workflow studio where you can drag and drop the components and have a workflow running up and very quickly. It has simplified orchestration for microservices, as we discussed, right? You can kind of basically they orchestrate the multiple steps into a single unified workflow, and it manages the input and output data, gives you out-of-the-box capabilities for exception handling and retries, all of those things, right? Second is improved application resilience. By what this means is that since it out-of-the-box provides retries, timeouts, and everything, so it is very easy for the application to resume from where it is, right? And it kind of ensures that any execution which has started will almost complete, right? In case of network drops or whenever the user is dropping off and coming back in the funnel again, right? The next advantage that we have is the reduced need in the integration code, because it kind of unifies all the distributed code into a single. Basically, you can unify all of the distributed components of an application in a single workflow, which basically reduces the need of you writing the integration code, right? And obviously, like you can, since it's an AWS, you can have a separate logic of your workflow, and the business logic would be kept separate, right? Any questions so far? We're good? Cool. So coming to the use cases that we have at CRED. So we extensively used step functions in a lot of our line of businesses. For example, CRED Mint, CRED Cash, which is the lending side, and CRED Shield, which is the insurance product for CRED, right? So in Mint specifically, we use it for onboarding, where the multiple steps in the onboarding journey are automated via the step functions. The steps could be PAN validations, Aadhaar verification, agreement signatures, bank management. So all of those are used and were powered by step functions. Similarly, Cash also uses step functions for onboarding and also to power the loans that they provide to the customers. And the insurance product that we have also extensively uses step functions for creating, updating, and processing the claims. Right? Sorry. So we'll quickly go over the application of how a step function looks like. So this is a very simple example of PAN validation, where you just take input of the PAN from the user, kind of validate it, and try to see if it's a success or a failure, right? So the first step is basically you take the PAN consent, where you ask the user to enter the PAN, right? Then this message moves to an SQS or can be processed by Lambda, where basically the SQS can return back to the step function saying whether this PAN is validated or not, and depending upon what was the success code for that, you can either retry back in case of failure, let's say up to some threshold, right? Let's say up to 3 times you want to take the input back, And if it is success, you can mark the workflow as success. And if you want to make, you can make the workflow as a failure. Right? So all of these retries, exception handling are part of the step functions that we use. It's provided out of the box for that. Right? Quickly discussing about the challenges in general for step functions, and then we'll discuss how these limitations has impacted CRED. Right? So in general, the application code in step function is little hard to understand because the code is all separated. So any new members or the new joinees in the team find it difficult to understand how step functions follow. Right? And the second is the proprietary language requirement. So it uses Amazon state language, which in general is a prerequisite to write any state function. Although they have given a drag and drop, but if you would want to write your own code, you will have to use the Amazon states language. Right? And then there are certain AWS limits which they have put on the step functions. For example, only 256 KB of data could be passed in a workflow at any point of time. And any execution or any workflow can only be kept running for 1 year. And coming to the maintenance of execution history, it is only maintained for up to 3 months. Right? So if you want to maintain log of what has happened previously, you will have to write your own pipelines to push this data from AWS to either Redshift or any other database that you use, right? So these are in general limitations of step functions, right? But what we face specifically at CRED is because we have lots of lines of businesses which are using step functions, and we use a common AWS account there. Right? So what happens sometimes is that one of the LOB, so step functions is a quota for any AWS account, right? The number of executions or number of activities that you can do per step function execution limit, right? So sometimes what we have seen is that one of the line of business ended up consuming the entire step function data for that account, which kind of degraded the performance of other lines of businesses within CRED. Right? So this has happened quite some time, right? When a new LOB goes live, people generally don't understand the quota, right? So this has happened, right? So this is what happens. This is the kind of exception which step functions throw up. It says throttling exception, which is rate limit exceeded. So this was the core problem that we wanted to solve at CRED, to kind of rate limit the step functions, right? And this is how we solved this via Kong. We leveraged the rate limiting plugin of Kong, and basically implemented the rate limiting for same. We'll discuss the steps in detail, right? So high level, talking about the high level steps, there were 2 changes which were required. One was in the client SDK, where you are writing your step function builder client, right? And then there were a couple of changes in Kong, right? So coming to step 1, this is a expert from Java, where you just have to introduce a new header which will denote your tenant. For example, mint is one tenant and cache is one tenant. So you can, okay, I'm not sure if the screen is visible, but there is a header that you can provide which says X SFN client tenant, right, which is cache in this case. And you also have to provide the Kong URL in the endpoint configuration, which will act as a reverse proxy for your service. So all the services will go to Kong, and then Kong will read out them to step functions. Okay, so next step is creating a service in Kong, for specifically for step function, where you can just create a service with host, AWS host, right? And rest everything remains same in the service. Step 3 is basically adding a route to that service. So the paths are set to / because all the AWS post requests to step functions they go through the / endpoint. And then we can set the tenant header, which will basically have the tenant level aggregations to reroute the request. And the next interesting thing here is that we can actually rate limit certain specific step function methods also, right? So step functions support multiple methods. Could be execution history, where you want to get the execution history of a step function, or you want to list the activities which are happening, or you want to list the tasks which is happening, right? So we can specifically also specify that which methods we want to rate limit. So in this case, we are kind of rate limiting the list activities of the step function. And the final thing that we have to do is set preserve host in the routes as, yes, we'll have to preserve the routes for that, right? And the last step here is that we'll have to enable the rate limiting plugin of Kong on this particular route. So once this was done, right, and once you basically configure your Kong and run your application, these are the kind of observations that we have noticed, right? So instead of the throttling exceptions that we were getting, which were kind of consuming the quota of step functions, we were able to rate limit, and we were getting these kind of exceptions, which is API rate limit exceeded, directly from the Kong instead of request going to the step functions. So this is largely how we solved for this. Yeah. Yeah, that's about it. Thank you. Any questions we have? Yeah.
After the Kong gateway blocks the, like you get the exception.
Yeah.
How do you further, do you like fine tune the Kong gateway API rate limiting so that my question is, doesn't the exception also degrade the application's
So
performance?
depends upon use case to use case, right? In some cases, we might not want to use a rate limiting plugin. For example, all the customer facing flows, right? You don't want to rate limit that, but basically you would want to have an alternate to not impact the customer performance. But there are certain flows which are like background processes, right? Which can be rate limited and can be handled via retries, right? So if let's say there's a rate limit of 2 requests per second for step functions, and any application is calling step function with 100 requests per second, right? We can avoid those kind of scenarios, just the background processes. Customer facing APIs or the flows which use step function they can still go without Kong, and we'll have to figure out another way, maybe exceed the step function quota or increase that.
Also, what happens when there's a, I'm not sure if there's like a marketing campaign run by CRED and maybe there's a sudden surge of users, and at that point multiple applications could be going for more of the quota of
Yeah.
so what happens?
So in that case, we basically pre-warm the systems, right? In case if you already know that there's some campaign which is going to happen, so you can basically already extend the quota for step functions to serve for that kind of traffic. So that is a pre-warm activity we do for any external event that we do.
Okay, so you pre-request more rate from the AWS before
Right.
the campaign. So.
Yes.
Got it. Thanks.
Any other questions?
Did you consider any other alternatives before moving into Kong? If yes, what were there?
No, I think Kong is the first one we tried because we already had support of rate limiting in Kong. So this was the first thing we tried and kind of worked for us. So we have not explored any other alternatives as of now. The other thing that we have done at the LOB level is ensure rate limiting in the LOB so that you don't end up consuming the data. But that is like, I would say, one of the very, very, initial moves that we have done in this direction.